Hello, hello, one and all. Can everybody hear me? I'll take that as a yes. Yes. Good, good, good. Okay, thank you, everybody. Right. I would like to begin my lecture with something we are already familiar with counting in base 10. This is known as the decimal system. And the symbols we use to represent the numbers we know are 0, 1, 2, 3, 4, 5, 6, 7, I'll show you in the rest, 8, and 9. To go further than 9 though, we need to start using combinations of these symbols. So to get 1 more than 9, which is 10, we get 1, then put a 0 afterwards. And I'm sure you can imagine how the rest goes because we have used it pretty much every day. Now, what if I told you there was an organization in the world that wished to change the way we all count? They wish to change the 10 lovely symbols we're familiar with to 12 symbols. They are called the Dozenal Society, and they believe using another system, which goes by the name of the Dozenal System, or the duodecimal system, is a much better way to count. So let's talk about the Dozenal System, which can be called base 12. It starts completely normal with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But to represent 10, instead of putting 1 and 0, use a new symbol called dec. And 11 is L. After this, the system is combinations of all these symbols, just like our system. So to represent 12, we write down 1, then 0, which is called do. And we can keep on going with this. We can get 1 do 1, 1 do 2, and we can keep going to skip a few, get to do dec, 1 do L, 2 do, 3 do, dec do, L do, and then we can finally get to do, which is written like that and can be called a gross. So now that we know what the system is, how could it ever be useful since we count in tens? Firstly, let me just say that this doesn't affect serious mathematics at all. Pi is still the same value, but it's just written differently. So what is base 12 good at? For starters, it would make everyday mathematics significantly easier. So let's list out the factors of 10 first. We have 1, 2, 5, and 10. So the factors of 12 are 1, 2, 3, 4, 6, and 12. 12 having many more factors makes everything so much easier. For example, in decimal, when we divide 10 by 3, we get a horrible number, which is 3.3 recurring. But in base 12, when we divide do by 3, we get 4, which just looks so much cleaner. Now for counting, let's try counting in decimals. For counting in ones, we have, well, that's easy, 1, 2, 3, and so on. You can obviously see a pattern. For twos, very easy. You get 4, 6, 8, let's get through these, 10, 12, 14, 16, 18, and 20. Now, if we look at the last digit of each of the 2-digit numbers, you can see there's a pattern repeating, 2, 4, 6, 8, 2, 4, 6, 8. Oh, I forgot the 0, of course, which will make counting for children easier. Now let's count in base 10, but in threes. We've got 3, 6, 9, 12, 15, 18. There's no easy pattern here to memorize. For us adults, who've been practicing maths for a long time, obviously we can count in threes, but for a child who's never learnt to count before, there's not really a nice pattern that they can follow. So let's try counting in threes, but in base 12 instead. So obviously we have 3, then we have 6, then we have 9, then we have do, then we have do 3, do 6, do 9, and 2 do. And this is a much more easily recognized pattern because it just keeps on repeating in base 12, which I think is easier. We have 3690, 3690. So obviously, well, yeah, you can see the pattern, I guess. So let's move on to multiplication. When we had to learn the multiplication tables in schools, it was such a horror because it was just, well, obviously it was just so hard to memorize. The multiplication table of Dozenal is much easier to remember than a decimal system, since there are way more patterns that occur. Now, if we look at the left column, we can see 1 obviously goes up to, well, we've already counted in ones, 2 goes up in 2, 4, 6, 8, and deck repeating. And if we go to 3, which we've already done, you can see the symbols repeating again. There's a pattern. 3690, 3690. For 4, it has 4, 8, 0, 4, 8, 0. Now remember, we're looking at the last digit of each number. For 6, it goes 6060, and so on. 8, it goes 840, 840. And even 9 is a pattern, 3690, 3690. And for deck, there's a long pattern, but it's still a pattern of deck 8, 6, 4, 2, 0, and deck 8, 6, 4, 2, 0 again. For L, we have a lovely countdown of L, deck 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. And of course, for Do, we have everything endings in zeros. So we can see that for children, base 12 can make counting, multiplying, and dividing much easier, since 12 has many factors. Now you may be wondering, why haven't we changed to the Dozenal system? And that is strange, but there are many examples of the Dozenal system in the world we live in. Our world is already dominated by 12s. Our clocks have 12 hours. Our years have 12 months. Eggs come in dozens, just like a pack of beer or Pepsi. When was the last time you went to a supermarket and got a pack of 10 for something? What a strange number 10 is now. Other measurements, such as 12 inches in a foot. For currency, we use 12 pence in a shilling, or we used to use 12 pence in a shilling. See, our world used to have so many 12s because it was much easier and natural to deal with. How can we see a future for this? Well, we could perhaps teach our future kids about the Dozenal system, but there is one huge argument against it. Many people say that because we have 10 fingers, it would be so much harder to learn how to count because the fingers on our hands make it so much easier to count. However, we can just use our thumb to count the segments on our fingers. It used to be crazy to have a 0. It used to be crazy to have negative numbers. It used to be crazy to have complex numbers, and I still find complex numbers crazy. But would it still be crazy to change to base 12 counting? And that concludes my short lecture. Thank you, everybody.
Thank you very much. That was brilliant. I'm enjoying all these comments coming in with the little claps. It's obviously not the same as being in person, but this has been really brilliant, and I've really enjoyed both talks from Shay and Theo today.